All right, so what do you think about number 4? Lauren, you got a plan? Or 5, I mean 5, I'm sorry. Number 5, Lauren? You got an idea?
Is that equal to each other?
Wait,
Sir, John?
we're on the worksheet I just handed out today. Are there more than one 5? Yeah, there are more than one 5. So we'll do your 5, Jordan. That's not the one that I thought. We'll do the other 5 in a minute. We'll do this one now. Yep, you're exactly right. So I want to set them equal to each other. I don't know who put this worksheet together. It's the 5s, but anyway. So 3 plus root 3 tan. No, can't blame Mr. Pasquale. This is all me. 3 plus root 3 tan equals 4. And I want to find the points of intersection. So as George so rightly said, we're just going to set them equal to each other. All right, so what do you want to do first? Yep, so we have root 3 tan equals 1. So tan equals 1 over root 3. Okay, so then, what? We gotta figure out where the tangent is 1 over root 3. Again, you just kind of have to process, isn't that 1/2 over root 3 over 2? Which means that your ordered pair on your unit circle would be, this is y over x. So it's root 3 over 2, 1/2. Now that's a lot. Did you follow all that step-by-step logic in your head? So what angle is that? Pi over 6. So one of the answers is indeed pi over 6, but there's another one because the tangent is also positive in what other quadrant? Quadrant 3. And what would be that angle? It's the pi over 6 in quadrant 3, 7 pi over 6. So there are the answers to that question. That makes sense to everybody? All right, let's go to the back page, number 5. The handwritten number 5. And does anyone have a thought on this one? Factor. All right, so we're going to factor it. Okay, this time 2 pi is included for whatever reason. All right, so how does this guy factor? 2 sine plus 1 sine minus 1, I heard her say. I don't know. I could check that, right, to make sure. So if I FOIL that back together, she's got the 2 sine squared and the negative 1. That's good. I'm worried about that middle term. Negative 2, positive 1. I think she's right. Do you think she's right? You got to be able to do that by yourselves, okay? Are we good on that? Do we have a question about that? All right, so what does that mean? That means sine equals negative 1/2, or sine equals 1. Now, I can find those points on my unit circle. There isn't a problem with that at all. I'll do these in black and these in green. So where does the sine actually equal negative 1/2? Well, if the sine is 1/2, then the angle is pi over 6, but it's a negative 1/2. So no, be careful, sine, y. You want it to be down here, at 7 pi over 6 and 11 pi over 6. I'll make this open. Everybody okay with that? And then, where does the sign actually equal 1? The only place it equals 1 is pi over 2. So, here are kind of my dividing lines. There's my green line. Here's my black line. Now, this is an inequality. You are multiplying these two things and ending up negative. So what does that mean? That means one of each. So black can be great, not or equal to. Black can be greater than and green less than. Does that make sense to you what I'm doing here? Or it could be the other way around. So black could be less than and green could be greater than. Now in terms of your circle, if you're doing this on the circle, greater than means above the dividing line and less than means below. So this says I'm above black, and below green. Wouldn't that be all of this here, guys? All right, so what is that? Well, now you gotta be careful because again, this is one piece, but you can't write it that way because you have to start at 0. So I'm going to talk about everything orange now. I got to write down everything orange, okay? Because that is above my black and below my green. So what's that going to look like? 0 to pi over 2. Pi over 2 to 7 pi over 6. And 11 pi over 6 to 2 pi. Now, notice that 0 is shaded. There's no dot at 0. It's shaded, so that's why it gets included on both ends. Is that all right with everybody? All right, what about case 2? I have to be below black and above green. That doesn't work. So if it did, then I would just add that answer onto this, but it doesn't, so that right there is the answer to the question. Is that okay with everyone? All right, let's look at the sheet. Let's go ahead and do number 6 because it's on the handwritten. The 6 right under that 5. And make sure we got this in. There is one inequality problem on your quiz. We practiced one somewhere a minute ago. One more. So 2 sine squared plus 9 sine minus 5. Okay, step 1. What are you thinking? You're thinking factors, right? And you got 2 sine and sine and minus 1 plus 5. And I see Jamie back there going like this because she's checking. She's doing her foiling to make sure she's factored right. Because if you factor wrong, these numbers are going to be wrong, and then your answer is going to be wrong. So you want to make sure that you got it factored right. Is everybody okay with that factoring? This gives me 10 minus 1, that's 9. All right, so this says sine equals 1/2, or sine equals negative 5. sine is y, right? What's the lowest it goes? -1. So my dividing line is down here, -5. So when it comes time to shade, which I will be shading, I am either going to shade the entire circle or I'm not going to shade any of it, right? If I'm above my -5, I'll shade the whole thing. If I'm below my -5, I won't shade anything. That makes sense to everybody? So no black dots, in other words. How about green dots? Where are those? Well, here's where the sine is 1/2. What are these angles where the sine is 1/2? That's pi/6, isn't it? Getting 5 pi/6? Now this time, we are greater than. Our factors multiply together and end up greater than. Okay? So what does that mean about the factors? They're either both greater than 0 or they are both less than. So I'm going to have a greater than and a less than case. Okay, so greater than, less than. Can I, after the conversation we just had a minute ago, can I just cross that one out? Because there won't be anything below this line. So that one's kind of gone. Greater than my black line is literally my whole circle. So my whole circle is this. And then greater than the green would be this part of it. So I'm trying not to shortcut too much. This is kind of an easy one. We're higher than black and higher than green. Would you say that's it right there? And that's easy to write. The answer to the problem is just pi/6, 5 pi/6. Okay? Got it? All right, let's look real quick at the sheets or anything else. How about 8? I think there's only 1 8. Let's look at number 8 real quick, and then I'll stop. 8 is an equation and I want to set them equal to each other. It's an equation, I'm setting it equal to each other. I'll use my unit circle, but I won't be shading on it because it's an equals. I only shade when it's a less than or greater than. All right, what do you want to do with this guy? Subtract. So 4 cosine cubed minus 3 cosine. Perfect. Then what? Factor out a cosine, leaving you with 4 cosine squared minus 3. All right? So what does that mean? Cosine equals 0, or 4 cosine squared equals 3. What are you going to do with that? Divide by 4. Square root, remembering the plus or minus when you take the square root of both sides. So now we have to figure out where is the cosine 0. Cosine is x, so that would be pi over 2, and 3 pi over 2. Everybody okay with that? And then I need a cosine that is an x value to be root 3 over 2. How big is that? Pi over 6. But since it's plus or minus, it is all the pi over 6s. So that would be pi over 6. Five pi over 6, 7 pi over 6, and 11 pi over 6. No shading, just list your answers because it's an equals. There's nothing to worry about extraneous unless what? When do we have to worry about extraneous? If we have a tangent in our problem, and if the angle is pi over 2 or 3 pi over 2. You don't have extraneous just because you have a tangent, but you can. All right, check that. All right. Okay, well, I'm going to finish. Stop there. You have a quiz tomorrow. So there's more practice here. Do something else. I don't care. But we have a quiz tomorrow. Okie dokie, Smokies.
I love this camera.